Hello all, welcome to my video. In this particular video, I am actually going to talk about the basics of data science life cycle, and also followed by what could be the capabilities needed by the person if you wanted to explore your career as a data scientist. And also I'm actually going to cover some of the tools which has been typically used by the data scientist, predominantly particularly in a IT driven project or a engagement. Okay, so that is the context of this particular video. So before I get into the video, let me quickly introduce myself. My name is Balaji, and I have somewhere around 24 years of experience in IT. I have actually extensively worked in agile driven engagements in the past. Now, for the recent few years, I am actually currently looking into the initiative of a merger, merger of Agile COE with DevOps COE combined with Enterprise AI COE. So, as part of this particular initiative, I actually got a chance to work with multiple data science related initiatives. So from that particular perspective, based on that particular pragmatic experience, I am just making this particular video to, number one, to actually give you a overall view of what are all the different phases involved in a distinct, a data science life cycle, followed by what could be the skills, what could be the capabilities or competencies needed by a person if you wanted to really become a successful data scientist. And then the third thing could be what could be the tools or what could be the libraries or the packages or some kind of the tech stack which you need to be familiar as part of the data science and life cycle journey. Okay, so this is the prelude or the context of this particular video. Okay, now let's go one by one. Let me start with the basics. Okay, now as you know, this basic concept of SDLC, right? Your software development life cycle. Similarly, even in a data science kind of a engagement, we have something like the first stage, second stage, third stage, fourth stage, because it's a pipeline, right? So you have a series of activities which you need to be cognizant about whenever you are typically trying to work as a data scientist in a data science life cycle kind of a projects. Now if you take a practical approach, right, you cannot directly become a data scientist, right? You need to start working as a data analyst, and then over a period of time you can actually become a data scientist, because a data scientist will have the capability to perform the role of a data analyst, but not vice versa. Means a data analyst may or may not have the capability to perform the role of a data scientist, right? Okay, now let us understand, like, if I want to execute a data science life cycle, if I want to go through the funnel of a data science life cycle project, what are all the different phases involved, right? Now the first thing is you need to define and clearly understand the problem statement, because see, be it a machine learning, be it a deep learning, or be it a generative AI, or be it a large language model LLM, what is that you are actually trying to do? You are trying to build a artificial intelligence kind of a system wherein the system has that intelligence to make data driven decision making. The data could be an image, the data could be a text file or a voice file, audio file, video file. All those are secondary aspects. But predominantly, all that you are trying to do is you are trying to build a system which has the intelligence to make a some kind of a decision making with almost zero manual intervention. That is the core funda of artificial intelligence. Now, if you want to become a data scientist, one of the place to begin the journey is you need to clearly understand, okay, what is the problem statement I am trying to solve? Am I trying to build an artificial intelligence system which will make a predictive analysis on the weather? or am I going to build an artificial intelligence system which is going to give a predictive modeling for the company's quarterly revenue margin, which can be typically reused in your QBR, quarterly business review, and in your EBR, executive business review meeting? Or am I going to build an artificial intelligence system to predict the volatility and the fluctuations in the share market? What is the system all about? Who is the end user? Why am I building? What am I building? That particular clarity and consensus is of a paramount importance. Okay. Now, having been said that you have understood the problem, then you may need to fundamentally you may need to build a model, right? And to build a model, you need to begin with collecting the data, right? So the data could be from the web scraping, or the data can be obtained by some third party APIs, or you pay, or no, or you have some avenues of possibilities to subscribe to a system. No, you pay the amount and then try to get the data from a trusted third party vendor. All those are secondary elements, but the primary fact is you need to collect the data, right? Now, you once you collect the data, I cannot use the data. I actually cannot use the data as it is, right? So that particular data can actually typically come from the third party API or your big data engineering team. We do have a concept called web scraping, right? So after the web scraping has been done, probably that particular data could have been saved in the cluster of nodes, so that the data scientist can then further take it for the downstream applications. So one of the point which we need to keep in the mind is, one is defining and understanding the problem. Second thing is, there should be some avenues of possibilities to collect the data, and then you cannot take the data as it is and then try to use it in the project. Why? Because you need to clean the data, right? Because the cleaning may not be the right technical word, but from a layman approach, the word we can use is cleansing the data, cleaning the data. Technically it could be called as a data pre-processing, and there is a concept called feature engineering. Within that feature engineering, you have a lot of concepts like EDA, okay, exploratory data analysis, all those concepts. And you have a concept called uh, dimensionality reduction. So all those concepts we can cover one by one in the forthcoming videos. For now, try to understand the basics that once you collect the data, you cannot use the raw data as it is to feed into a model. See, what is a model? A model is a simulation. No, it's a kind of a simulation engine which will take your inputs and then try to process that particular inputs and then give a particular output. Now, every model comes with an assumption, every model comes with a dependency, limitations, and constraints. The moment you understand the limitation of the model, the more you have a grip on the model, right? See, like in the times of COVID-19, people started building models to actually simulate the vaccine creation process, to actually just get to know how does the DNA and RNA really interact within the human body, so that I can actually create a vaccine. But then the problem here is, by the time you try to simulate that particular vaccine creation activity by doing some analysis, the COVID also gets mutated, right? So every model will have a limitation. Even if you take a Monte Carlo simulation technique, it has its own advantages and disadvantages. It has its own pros and cons. So just to cut a long story short, you need to be clear on which particular algorithm can be used in the field of a data science whenever you are trying to create a model. So in the forthcoming videos, let us take most of the commonly used algorithms, and then I will try to explain you at least on a high level. Now let us assume that now you are actually clear with, we need to have the clarity and the consensus on defining and understanding the problem. Second thing, you have collected the data from some trustworthy sources. And the third thing, you are going to clean the data, you are going to pre-process the data so as to make it deemed fit to enter the funnel of a model. Now, in the model, once you have built the model, you also need to deploy the model, right? Let's say that you have created a model, you are going to monitor the model, you are going to evaluate the model, test the model before you go and deploy it. And one of the point which you need to take care is, once you actually deploy the model, you also need to monitor the model, let's say for a period of 30 days. No, depending on the context, that period of monitoring the model will keep changing. All that I'm trying to say is, after data cleaning or cleansing, you have a data pre-processing, and we have a concept of exploratory data analysis, because you have a concept called a curse of dimensionality, and you have a concept called a dimensionality reduction, and you have a concept called a PCA, principal component analysis. So those things we will see one by one in the forthcoming videos. So once you apply your exploratory data analysis, because the point which we need to keep the point which we need to keep in mind is, if you have the data, right, your particular data set could be an imbalanced one. So you may need to take some measures to remove the noise from the data, because, and you may also need to format the data properly. Only then you can apply your machine learning algorithm, right? So you have something like a wrangling technique, all those things. You have something called a normalization, and you also need to know how to handle categorical features. So these things we will cover in the forthcoming videos. And once you are done with this, you may need to get into the funnel of a feature selection. You need to select the feature set, data set, and then you may need to create a model. Okay, and then you need to be once you see, you need to be very clear on what could be the closest algorithm which we can use to create the model. One of the problem or the challenge what I see is, because a data scientist only knows only 4 or 5 algorithm, doesn't mean that you will try to force fit that particular algorithm into the context. Absolutely no. You need to understand the context and then pick up the right algorithm, closest algorithm as per the dynamics of the context. Okay. Then once you are done with this, once you have selected the model, once you have created it, and then you may need to tune the model, you also need to test the accuracy of the model. We do have a concept called hyperparameter tuning and hyperparameter optimization. Okay. So once you are done with all these particular phases, then you can actually go to the deployment of the model. So in most of my engagements, which typically involve a data science kind of a flavor, we actually have something called as a Flask model. Okay, so using the Flask model, we actually create a REST API service and then deploy it, so that from the front end, with some minimum customization, it can be consumed. Okay, that is the funda. Okay, now once you have created a model, you tested the model, and then you deployed the model, you may need to give different sets of inputs to the model, and then see how does the model really performs in a real world context. See, anyone can predict the future, but what is more important is how far the prediction is closer to the reality, right? So your reality will not work as per the model. You need to build a model which is going to mimic the reality, right? So this is the basic concept involved in the field of data science. So all that you are trying to do is, you are trying to take the existing data, understanding the business problem. You are trying to build a model which is envisaged, which is expected to give solution to a new input set to the model, and it will give you an output. Now based on that particular output, you can make a data driven decision making. You can take informed choices. See, when that inputs and processing mechanism is very clear, decision making need not be viewed as a separate activity. It is more of a continual approach rather than a discrete activity. Okay, that is what no, I no, I'm actually trying to tell. And one of the concept which I generally tell to my team, my clients, and other business people know in that particular ecosystem is models are not used just to predict the no, just to predict the future. Models are also used to explore the possibilities in the future. So from that perspective, you may need to create a model. Okay. So this is the fundamental concept which we need to keep in mind. Now what we will do is, let us now try to understand what are all, okay, now what are all the different aspects which you need to know. One thing is that you need to know how to do the data cleaning, and followed by how to pre-process the data, because your raw data often contains some inconsistency, missing value, null values. So data cleaning is an essential thing to ensure data quality, which will directly impact the performance of any no model. Okay. Now the second thing which you need to keep in mind is, you may need to do something called as a feature engineering. So there we are going to create new features or transform the existing one, which can significantly improve the model performance, right? Okay, now these things we can see one by one in the forthcoming videos. I will take feature engineering as one playlist, and within that playlist I will create 4 or 5 videos, because in single video, if I keep explaining the depth of the subject, it will be very difficult for me to cover the breadth. Okay, now also you need to be good in statistical analysis and hypothesis testing. Why? Because if you are actually working on a project, you are going to validate a particular assumption, right? So you need to know which particular hypothesis testing, which particular proven mechanisms in place, something like a confusion matrix. All those concepts you may need to know at least on a high level. Now let us think practically. Let's say that you have created a model, all those things. One of the important capability needed is data visualization. Why? See, visualization is more of presenting a reports to the stakeholders, so that they can see the report and then take informed choices. Now, visualization reports can be either created using Power BI, or you can no, you can might as well create it using a no Tableau reports. Okay, because Tableau also has a lot of inbuilt features, based on which whenever you are trying to do a data visualization, it is going to help you in uncovering the patterns, no, the trends and the insights, which are not easily visible in a raw data format. See, if you have a data, if you have an Excel sheet, by looking into the Excel sheet, you cannot just like that tell, no, it is very difficult to pull out inferences from the huge data set. But then the moment you try to convert it into a bar chart or a histogram or some kind of a pictorial representation, the moment you translate it into a visual thinking, human mind can comprehend it in a better manner to see the pattern analysis and the trend, right? So data visualization is one of the very important capability needed for a data scientist in the long run. Okay. Now on top of it, as I already mentioned, you may need to know what are all the different machine learning algorithm. You are writing an algorithm to make the machine to learn something. Now concept says you have something called as a supervised learning, you have something called unsupervised learning, and also you have a reinforcement learning. Now depending upon the situation, you may need to take a call which particular algorithm will be the closest fitment. Okay, I may not say the best fitment, but the closest fitment, depending on the constraints of the ecosystem. So when I'm going to create a playlist exclusively for machine learning algorithm, there I will put some four or five videos in it. In this particular video, I am actually trying to explain you what are the different 7 colors of the rainbow for a rainbow called as a data science. See, for example, One of the example which comes to my mind is for one of my client last year. There was a situation or a context wherein I need to do a customer segmentation. Like, so if I want to do a customer segmentation, I actually went for a k-means clustering, because k-means clustering is an unsupervised learning algorithm which will enable me to group the customers, existing customer base, into different segments based on their purchasing behavior, based on their purchasing pattern, which will help me to make some targeted marketing effort. Okay, in this geographical region, these are okay, this is the quantum or the volume of the customer base predominantly buying the predominantly buying the entity one during the season April to June. I'm just giving an example. Whereas in this geographical location, this is the customer base, quantum of the customer base predominantly buying an entity 2 during the month of September to November. So what are you trying to do? You are trying to understand the existing purchase behavior of the people, and then you are trying to create different segments, and using that thing you are creating a model which will help you in making targeted marketing effort. And K means clustering is one of the closest thing which you can use in this context. See, the one of the challenge where multiple data scientists struggle is it is not just knowing 50 algorithms or 15 algorithms. You also need to know which particular algorithm to use where and how, and most importantly, why. Okay, let me repeat this line for the benefit of the larger audience. It is not enough if you know all the algorithms. You will also need to know what are the pros and cons of different algorithms, which given a situation or a context, which particular algorithm you may need to use, how to implement it pragmatically, practically, and most importantly, why am I taking that particular algorithm. And an algorithm which is used for market trend projection may not be relevant to use in a epilepsy recurrence pattern, right? If I want to build a artificial intelligence model taking into consideration the patient metadata and the EEG signals and the history of the patient, I can even create an artificial intelligence model to predict the probability of occurrence or recurrence of uh, uh, epilepsy or a seizure. And on the top of it, the neurologist can do some kind of a analysis. See, always understand an important point. Models are most likely supplement to make a decision. Models are not generally substitution for a human intelligence. You may still need to take the insights from the model before you give a final tick. But over a period of time, if your model gets refined to an extent, then probably you can slowly eliminate the need for a human intervention over there or a subject matter intervention over there. So these are the points which you need to keep in mind. Now, once you have built the once you have selected the right algorithm, once you have built the right model, then probably you may need to have a mechanism in place to evaluate the model performance. So we have something called as a F1 score. Okay, F1 score you can probably use. So in my future videos, I will be talking about confusion matrix. I will be talking about recall curves. All those concepts will be thought over there. Now, these are all some of the things which you need to know. Now, on top of this, you need to have a solid programming language capability. It could be a Python or it could be an R programming language, but I generally personally prefer Python, because Python skills are foundational for your data manipulation, your analysis, your model building, and also for the deployment. Because much of my junior data scientists, they actually typically use Python libraries which are like NumPy, pandas, and you have matplotlib, and you have lot of inbuilt library features as packages for your data pre-processing, and you also have some kind of an inbuilt packages for your machine learning, and also you need to be good in your SQL for querying the database to extract the uh, data, right? So based on the queries what you write. Okay, so if you just pause this video and then try to recap from the beginning, right? Data science is a multifaceted capability. It is not that you need to be good only in the programming. It's not that you need to be good in only in the mathematics, all those things. You need to be good in everything, at least to a reasonable extent, for you to build an effective and efficient model, and then you may need to deploy the model and then continuously monitor it. Now, one of the other capability which actually comes to my mind is you also need to be good in some of the big data tools and uh, te- technologies. Why? Now you think practically. In a data science project, you are typically going to handle large volumes of data, which will be critical for a data scientist to work on the projects, right? So in some of the projects, right, when we started building a real time recommendation engine, let's say for a e-commerce portal, so some of my team members typically use Apache Spark for processing the large data set, and they also use Kafka for a real-time data streaming to actually build a scalable and high-performance data pipeline. See, these activities you can take it as a pipeline. Every activity in itself is a pipeline. Then you may need to integrate the different pieces into a single flow orchestration. Okay, so these are all some of the points which you need to do. Now, one more important point, what I generally recommend the data scientists to be cognizant about is you need to have at least the basic domain knowledge, right? See, if you are working in a finance project, at least you need to know the BFSI basic concepts, right? If not, you cannot speak the language to the product owner or the product manager or to the compliance team. So at least based on your domain, it could be finance, it could be automobile, it could be healthcare. At least try to have a little bit knowledge at least on the basics of the domain. What could be the typical challenges, how to overcome it, what could be some of the best practices. See, for example, if you are working in a BFSI, which is a highly regulated environment, it has lot of governance mechanism, it has lot of compliance aspects, FATCA, JATCA, all those things. So at least you need to know, okay, these are all the totality of workflow which I need to handle. So how am I going to simulate all these particular things? Okay, so if I try to give a brief summary view of what we have discussed till now, is we have started understanding the life cycle of a data science project. It actually begins with defining and understanding the problem. You try to collect the data from n number of sources, and you cannot just like that take the data and then put it inside the funnel of your model, right? So you also do something like a data cleaning, okay, technically called as a data pre-processing, and you have something called exploratory data analysis. You have the concept of a feature engineering, and then you actually need to build the model and then deploy the model. Once you deploy the model, you also need to evaluate the model continuously and then monitor the model. Any kind of a course correction, you may need to repeat the cycle depending upon what is the degree of discrepancy, whether you need to go from data collection or you need to begin the journey from data cleaning. That actually typically depends upon what is the degree of a discrepancy in terms of the outcome given by the model. This is the basic concept. Okay, if you are very clear with this basic concept, then what you can do, you can take piece by piece, okay, and then focus on data cleaning. So when I create my playlist, I'm also going to create in this manner only, data pre-processing playlist. Within that, I'm going to put 4 or 5 videos, hands-on videos. Okay, it's not like this video. I will share the screen. and then I will try to simulate it using a trial version of the software in my personal laptop, because as obvious I cannot expose my official aspects of the work on a social media platform, right? So within the limited environment, I can try to I can try to simulate it, and then I can show you. That is not a big problem or a concern. Okay, now let us go to one more understanding. What are the top tools? Okay, see, for example, if you are working in a data science project, what are the top tools? What are the top applications or libraries or packages that can be used by the data scientist in your day-to-day work? Okay. Now let us begin one by one. First thing, when you are working on a project, you need something called as a IDE, right? Integrated Development Environment. So in the Java days, we all tend to use Eclipse IDE, but in the data science project, you have something called as a Jupyter Notebook, JUPY. Don't put I. Okay, I is for the planet. Okay, this is JUPYTER. See, when I'm making this particular YouTube video, okay, it is not for a particular target group. We may have different people with different capabilities, and some people will be very new to IT itself. So this video should even help those particular people. That is why I'm actually going up to the spelling level. So one thing is a Jupyter Notebook, Jupyter. So Jupyter Notebook is an open source web application which will allow the data scientist to create and also to share the documents containing a live code. It could be an equation, it could be a narrative text, or it could be a visualization. Because Jupyter Notebook, what we used to do, we extensively use it for our EDA, which I already covered, exploratory data analysis, and also for our visualization. Okay, so data scientists typically used to write and execute their particular piece of code in this particular environment, and much of my teams typically use Python as the language. So the first tool which you need to know is something called as a Jupyter Notebook. Now within the Python, you may also need to know what are the frequently used libraries for your data manipulation and analysis. One is called Pandas, PANDAS. So Pandas is an open source data manipulation, and it is an analysis library for a Python Python language. Okay. Now this particular package or this particular library is been extensively used for data cleaning, data transformation, also for merging, and also for aggregation related task, because this particular pandas is actually critical for data pre-processing, which is often the most time consuming phase in the data science. See guys, when you are going through the funnel, right, you should not exhibit the triad of urgency to build the model immediately. Data science is not about just building a model and then deploying the model. Yes, building a model and deploying the model is a very core part of the work, but that will not take more time. You need to build the right model within the constraints of the ecosystem, right? So the second thing what you need to know is you may need to be familiar with this particular pandas, okay, in the world of Python. Okay, now third thing is NumPy. Okay, NUMPY. NumPy is fundamentally it is a package for numerical computing in Python. Whenever you are trying to do any kind of a numerical related computation in the world of Python, you can go for NumPy. So NumPy has the capability to providing the support for arrays, matrix, and also many other mathematical functions. Okay, so just to cut a long story short, if you are going to perform any kind of a mathematical operation on a large multi-dimensional array, then probably it is going to involve lot of mathematical functions, right? In that case, you can go for a numpy. Okay, so I'm just giving you a high level view here so that you can take notes, and then you can actually do more kind of a Google search, all those things. Okay. Now, another thing which you need to keep in mind is, as I already mentioned in one of my videos, you have something called as a machine learning and an advanced version of machine learning. Probably I actually tend to call it as a deep learning, which is basically based on the concept of a neural networks. Now you have something called as a TensorFlow. TensorFlow. TensorFlow is an open source platform developed by Google for machine learning and deep learning. Why? Because what these particular data scientists tend to do is they use a TensorFlow to develop deep learning models and then train them on large data set and then deploy them. Okay, so whenever you are trying to think about machine learning and deep learning, one of the popularly used open source platform is TensorFlow. Okay, now, and as I already mentioned, whenever it comes for a powerful data visualization tool, you can either try to master Power BI or preferably Tableau reports, so that you can use that particular reports for creating visualization that make complex data understandable and also actionable. See, understandable is actually one thing, which is an information, but there is no use of information without a transformation, right? So you can use your Tableau report to create a visualization which will make the complex data understandable, which is part one. The part two is you take actions based on that. If not, why are you doing it in the first place? And then actionable for your different target groups, right? So one of the tool which you may also need to know is Tableau. And as obvious, whenever there is a database involved, right, you may need to use a domain specific or a query based language, so preferably SQL, right? So if you are taking a SQL, it is a domain specific language used for managing and querying the data stored in a RDBMS, relational database management systems, which you all know. Okay, so something on the back end, some code is been written on the front, like you have a Python code and you have a database. Okay, you also need some kind of a Power BI or a Tableau reporting mechanism. All these things are fine, and already we have actually touched about some of the libraries or reusable packages which you can use in the world of Python. And I also talked about TensorFlow as an open source platform for your deep learning model. All these things are fine, but what about deployment? Then you go for a Docker. So typically if you take concept, Docker is a platform that uses OS level virtualization so as to deliver software in packages. If I want to use the technical word, it is called as a containers, right? So much of the data scientists typically use Docker to containerize their applications and environments. See, in a large product company, you have a separate machine learning expert and all those people who will take care of Docker containerization and deployment. Whereas in it's not always no, that you actually get that particular luxury of a ecosystem. Okay, I have seen in some of the companies, data scientists themselves need to build the model, test the model, also deploy the model to the prod, and also continuously monitor the model. Okay, and before I close this particular video, what I wanted to tell is, you also need to be knowing the basics of Git and GitHub. See, there is a difference between Git and GitHub, because Git is a distributed version controlling system, whereas GitHub is a platform wherein you can host your Git repository for your better collaboration. Okay, let me just repeat it. Git is a distributed version control system. Source code management or a version control system is called Git. Whereas GitHub is a platform wherein you can host this particular Git repositories, and then you can actually do collaborative coding and all, right? Okay, so okay, now these are all some of the fragments. Okay, I'm just given a very high level view. Okay, these are all some of the the fragments. What are they? Jupyter Notebook. I have talked about pandas. We have talked about NumPy. We have also discussed about TensorFlow. We also talked about Tableau. Okay, and we also talked about Docker, GitHub, and I also spoke about SQL. Now, one of the other important thing is Apache Spark. Okay, where this particular Apache Spark can be used. See, Apache Spark can be used either in data preparation, data collection, data exploration, analysis, model building. But what it does, uh, okay, this particular Apache Spark is used for processing large scale data. If your quantum of data is very high, Apache Spark is used for processing large scale data during the data preparation and also during the exploration phases. Okay, now whenever you are trying to build a machine learning model, you have something called as a mllib library for distributed computing. So you also need to know the basics of this something called as a Apache Spark. Okay, I think I have covered by and large most of the things. Depending on the need, if you want to do a cross validation, if you want to do a hyperparameter tuning, all those things, depending upon the context, then we can pick up the correct package or the library from the Python. Okay, see, the purpose of this particular video is that I'm actually making this video with a good intent to help you people to understand the different fragments in the landscape of uh, data science. Okay, don't expect to master the subject within a short span of time. It's not going to work out. If you really wanted to master the complete data science, it may even take 15 months to 18 months journey. In this video, I am saying, guys, these are the different colors of the rainbow. Because for you to define a rainbow, you first of all need to know what are the different colors, right? And the right colors. It's not that any 7 colors can be packaged as a rainbow, correct? So, if you wanted to become a successful data scientist, right? First of all, we need to know what are the roles and the responsibilities of a data scientist. Second thing, what kind of capabilities, what kind of competencies are really needed by the person to become a successful data scientist. The third important thing which we need to keep in mind is what kind of tools and technologies are already existing in the market, so that if I master those tools one by one over a period of time, then I can master the entire gamut of cloud called data science. Okay, now with this particular understanding, I pause this video here. Now what I'm going to do is, in my subsequent videos, I'm going to create a playlist. Let's say I'm going to create a Tableau playlist. Within that particular Tableau playlist, I'm going to show you with a hands-on. I'm because in my personal laptop I have already installed a trial version of Tableau. So I'm going to show you what is the navigation, how you can create simple reports, all those things. Like that, we will explore one by one. Python, Tableau, SQL Server, TensorFlow, what are the different packages which are available. Then probably you go to the phase of deploying the model and then monitor it. So that particular learning process should be a enjoyable process. It should not be like in a triad of urgency, you try here, this, that, and then you actually miss the game. If you are unable to eat a cake, right, slice the cake and then take piece by piece. Same thing applies here for data science also. But then you need to know, okay, how does the cake look like, right? For that reason only I have made this video, to give you an overall know the view. So if you have any comments, please feel free to drop it in the YouTube video when I'm going to upload this particular video onto the YouTube platform. And then one more thing is, I am actually making this video on 16th September 2024. Typically in the first week of January 2025, I am going to start my own data science mentorship program for aspiring data scientist role. So if in case you are interested, you can probably connect with me at that time, and then you can join my data science mentorship program, wherein I will handhold you. I will personally guide you, coach you, mentor you to actually become a successful data scientist. See, I will teach you fishing, but you need to go and then catch the fish. That's the role of a mentor or a coach, as a improvement enabler in your career trajectory. Okay. Hope to meet you soon in some other video. Cheers and take care. Okay, bye.